This video covers nautical miles and knots. A nautical mile is defined as the distance travelled on the surface of the Earth when 1 minute of angle is subtended at the Earth's centre. 1 nautical mile is approximately equal to 1.852 kilometres. 1 knot is a speed of 1 nautical mile per hour. The definition of nautical miles means that if 1 degree is subtended at the Earth's centre, then 60 nautical miles have been travelled upon its surface. We could adapt our distance upon the Earth's surface formula as follows. For distances north or south on a meridian of longitude, we could use the formula d equals 60 theta to give a distance in nautical miles. Or for distances east-west along a parallel of latitude, d equals 60 cos alpha times theta. Let's see how this works out in a few examples which will work together. The first of these examples asks us to find the distance in nautical miles between two places that are on the same longitude. For this type of example, a cross-sectional view of the Earth is best. One place is 20 degrees north and the other 35 degrees south of the equator. The formula for north-south travel in nautical miles is distance equals 60 theta. Theta is the angle subtended by the travel, and it's shown in red. In this case, we need to add the latitudes. 20 plus 35 equals 55 degrees. The rest of the calculation for the distance is fairly easy. In the second question, we were asked to find the time involved in a flight and were given a speed of 450 knots. It is always important to read each question carefully, as some questions are written in knots and others are in kilometres per hour. If the speed is in kilometres per hour, then you want the distance in kilometres. But if, as in this example, the speed is in knots, then you want the distance to be in nautical miles. This question involves east-west travel, so a plan view diagram is appropriate. B is 110 degrees east of the prime meridian, and A 138 degrees to the west of the prime meridian. We are going to use the distance formula, distance equals 60 cos alpha times theta. Theta is the angle subtended by the travel, shown in red on the diagram. To find this angle, we're going to have to add together the two angles and then take them away from 360 degrees. Theta is equal to 112 degrees. Now we're all set to calculate the distance from A to B in nautical miles. But the question asked us for the travel time, so we need to turn to our old distance speed time formula. These formula work just the same when using nautical miles and knots. Time equals distance divided by speed. That's a distance of 6,314.73 nautical miles divided by a speed of 450 knots. Convert your final decimal answer into hours and minutes. And one last thing to show here, because I know that some students have difficulty in remembering speed, distance and time formula. This triangle summarises 3 different formulae. Now the triangle itself is easy to remember because it occurs in alphabetical order. D comes before S, which comes before T in the alphabet. To use the triangle, you cover up the variable that you want to know a formula for. So for example, if we want to find up our formula for distance, cover up D and you'll find that D is equal to S times T, or distance is equal to speed times time. If you want a formula for speed, then cover up S and you'll find out that S equals D over T, or speed equals distance divided by time. And if you want to find out a formula for time, then cover up T. T equals D over S, or time equals distance over speed. 3 formulas are summarised by the one handy device.